वेलकम माय डियर स्टूडेंट, वेलकम टू माय चैनल फिजिक्स जेन। तो आज हम लोग जानेंगे कि बैंड थ्योरी के बेसिस में इंसुलेटर, कंडक्टर और सेमीकंडक्टर को कैसे डिस्क्रिमिनेट किया जा सकता है। वेरी इंपॉर्टेंट थ्योरी है जो बैंड थ्योरी। So we know that there are three types of substances. One is insulator, conductor and semiconductor. Insulated, conductor or semiconductor. But if I ask you that why conductor means the which conduct current effectively. Insulator does not conduct current and semiconductor conductivity is between conductor and insulator. The conductivity of conductor is 10 to the power 2 to 10 to the power 8 ohm per meter, where the insulator conductivity is 10 to the power minus 8 to 10 to the power minus 18 ohm per meter. And semiconductor conductivity lies between conductor and insulator, that is 10 to the power minus 5 to 10 to the power 6 ohm per meter. So if we ask you that why the conductor like gold, copper or silver carry more current, whereas the insulator like glass, quartz, wood does not conduct current, then what is your answer? You say that आप लोग बोलेंगे कि ये फ्री इलेक्ट्रॉन का चक्कर है, फ्री इलेक्ट्रॉन इंसुलेटर में कम है, नहीं है, इसलिए वो करंट कंडक्ट नहीं करता है और कंडक्टर का ज़्यादा है। पर मेरा क्वेश्चन है व्हाई द कंडक्टर हैव सो मच फ्री इलेक्ट्रॉन whereas the insulator does not and semiconductor has some number of free electrons between the कंडक्टर एंड इंसुलेटर। सो आज के वीडियो में बच्चों हम ये जानेंगे। सो इसके लिए हमें जो जाना पड़ेगा वो है कि एनर्जी लेवल्स। यू नो द कॉन्सेप्ट ऑफ एनर्जी लेवल्स फॉर बोर एटॉमिक मॉडल। सो द एनर्जी लेवल्स आर द इलेक्ट्रॉन्स एनर्जी लेवल्स आर फॉर एन आइसोलेटेड एटम। इफ वी टेक द आइसोलेटेड एटम, then the energy levels of the inner electron and outer electrons are like this. The energy levels of the inner electron are like this and the outer electron are this. That is, this is for outer electron. This is the energy level for outer electron and this is for inner electron. That is, there is sharp discrete energy levels. But when we consider a crystal, that is the more number of atoms are connected together in a crystal, then the outer electron are interact with the other atom. We know that the outer electron are shared by more number of atoms. So in the case of crystal, the outer electrons energy levels, this is the energy level, this is energy level, okay. So the outer electron energy levels are altered or modified for case of crystals, but the inner electron energy levels are same, remain same. For crystal the inner electrons energy levels are remain same, but the outer electron energy levels are slightly modified, that is the energy levels are not here sharp or discrete. In spite of a single energy levels, it is split into a large number of closely spaced energy levels. So this is the energy levels for outer electrons. So in case of crystal, the outer electrons energy levels, this is the energy level is inner electron for crystal, which is same as the isolated atom. But for crystal, the outer electrons energy levels are split into more number of energy levels which are closely spaced, and we know that when the energy levels are closely spaced, it is called band. Band is a collection of energy levels. Now This is the concept of band in solid. Now we can consider two types of band. One is conduction band and other is valence band. What is valence and conduction band? The valence band is nothing but the band which is almost filled with electrons. When electrons are filled in the band, it is called valence band. So there are two types of band, valence band and conduction band. Valence band are the electrons in which valence band are bands in which the electrons are completely filled. And the properties of valence bands are such as, here the electrons are completely filled and the uppermost energy level in the valence band is called Fermi level. Fermi level. The uppermost energy level at 0 Kelvin is called Fermi levels. So the valence band are completely filled by electrons. Number 2, it is maximum energy levels. It is maximum energy level. The energy level of valence band is maximum. Number 3, the electrons, we say E minus, the electrons are not conduct electricity or current. Because the electrons here are not gain sufficient energy from the electric field. So number 4, they do not gain energy from external electric field. So it is clear that the valence band electrons are not related to any current in the material. Now if we say the another level band which is known as conduction band. This is valence band and this is the conduction band. In conduction band is partly filled, not full filled. It must be either empty or completely filled. So now we go with the properties of conduction band. The conduction band are related to the conduct electron or electron current. So the properties of conductor band is, number 1 is conduction band. It is partially filled. By electrons. Number 2, electrons gains energy from external electric field. Okay. Number 3, it conducts current in material. It conducts current in material. So the conduction band is either completely empty or partially filled by electrons. Now the gap, if we say that this is the conduction band, we can say the CB and it is valence band VB. So the lowest energy levels, it is the VB minimum and it is VB maximum, that is maximum valence band energy levels and minimum valence band energy level. And the conduction band, it is the conduction band CB minimum and CB maximum. Now the distance or gap between the CB minimum and VB maximum, that is the lowest energy levels of conduction band and the highest energy levels of valence band, is called band gap. We can say it as EG. So we can say that band gap Eg must be equal to Cb minimum minus Vb maximum. On the basis of this band gap, different materials are formed. So now we can make difference between the band gap of metal, insulator and conductor. So at first we go, why conductor conduct current? Here one thing you should know that for conduct current, the conduction band must be filled with electrons, either completely or partially. If there is no electron in the conduction band, no current will flow. So for metal there are two possibilities. Number one, valence band and conduction band are separated by very small energy gap. This is valence band and conduction band are separated by small energy gap, and conduction band is partly filled. Conduction band is partly filled. Valence band is fully filled and conduction band is partly filled. Okay. Number one possibility, or number two possibility is valence band is fully overlapped with conduction band. Suppose this is valence band and conduction band. So valence band and conduction band are overlapped with each other. Here the conduction band is totally empty. Totally empty conduction band. Conduction band is totally empty, but valence band is totally full, but conduction band is totally empty. But due to overlapping, it is seen that the conduction band is partly filled. Conduction band is partly filled because due to overlapped. So the band gap is very small. Band gap Eg is very small for metal, or conduction band is partly filled, overlap, that is the band gap is 0. So it conduct current. But in case of insulator or semiconductor devices like germanium, silicon, the band gap is large compared to the metal. For insulator, the conduction band and valence band, suppose this is valence band and this is conduction band, Cb and Vb are so separated that the band gap of the order of 3 electron volt to 6 electron volt, such as for diamond it is of the order of 6 electron volt. So this energy, this is filled with electron, here empty, here the band is empty, no electron reaches from valence band to conduction band as the band gap is very large. So no conduction electron in the conduction band and no current flows. Here no current flows. In case of semiconductor, the conduction band and valence band are separated. Valence band are fully filled and conduction band are empty, but the band gap here is small, that is from 0.1 eV to 1 eV. Such as silicon have energy gap around 1.1 eV and germanium have energy gap 0.7 eV. So this is small compared to the insulator. So at 0 Kelvin they are behave like insulator. No electron jump from valence band to conduction band. But when thermal agitation occur, that is the increase in temperature, some electrons reaches from valence to conduction band. Some electron reaches from valence to conduction band, so the conductivity increases of the insulator. So at 0 Kelvin, semiconductor behaves like insulator, but during increase of temperature, it behaves like metal or conductor. That is, its conductivity increases. But due to increase, the conductivity of metal is decreased, but conductivity of semiconductor increases. So on the basis of band theory, we know the differences. We can differentiate the metal, insulator and conductor. So आई होप आज के वीडियो आपको अच्छा लगा, कुछ जानने को मिला। ऐसे नए नए वीडियो के लिए मेरे चैनल को सब्सक्राइब कीजिए। अगर ये वीडियो अच्छा लगा तो लाइक कीजिए। आज के लिए बस इतना ही। थैंक यू वेरी मच।